Okay, so we're getting the new generator, the 35 kilowatt Briggs Stratton generator. So we've made some changes here. I've had the concrete guy pour a base. It's, as you can see, 5 inches. 1, 2, 5 or maybe a little more inches of steel reinforced concrete. There's rebar running throughout it. And the next job is I'm going to have to take out this wire, which is 6-gauge wire for the 20 kilowatt generator, and put in a much thicker 2-gauge wire. So I'm going to have to take this out. I'm going to attach a cable to this and pull it in, and then attach the steel cable to the new wire and pull that in, so I don't have to go through the crawl space, because the crawl space was a nightmare. The crawl space, you really had to crawl. It was I had about 12-14 inches vertically and horizontally. It was a nightmare. So if I can pull it through with a cable, I won't have to go in there again, which would be nice. And the next issue is the gas line is there. As you can see, it's a 1-inch gas line. It's probably not big enough to run the generator at full load. I have some concerns about that, but I'll probably only need to run it at half load anyway. So I think I'll be okay. And if I have to replace it, I'll deal with it then. We'll check it out. We'll test the generator, see if it's able to keep the hertz up. And if there's a problem, I'll know it's a fuel issue. So we'll check that out. So in the meantime, we have the slate board. It's dry, very solid, very heavy, and we'll be waiting for the generator to come. It's cool. That's good. I think that's fine. I think that's as good as we're going to get it.
Alright, what I'll do is I'll just even it up a little bit.
Great.
If I can.
Great, thank you.
So it looks a little prettier.
Thank you.
Just, you want to move them 2 blocks?
Yeah, hold on. All right, we'll stop. So we got it in pretty good. Nothing got damaged. Got to put the bush back. We lost the sprinkler head. And otherwise it's in great shape. Though there are a few scratches here. Very minor, but fortunately it comes with this, probably when Joe was getting it off the truck, it comes with the touch-up paint. So I'll just touch it up. It's easy. Alright, that looks good. I think when they were getting it off the truck, it rubbed up against the package next to it, the box, and I think it just scraped off a little paint, but it's no big deal. Just use a little drop of paint and no one will notice. Alright, everything else is in great shape. Really nice delivery. No damage. No real scratching. I'm really happy we got it on the block. On the concrete. That was fantastic. I thought I'd have to pay someone else to get it on the block. But taking care of Joe, giving him a nice tip, that was all that was needed to get it done. Okay. So here we are, back with the generator. I actually put car wax on it just so that it wouldn't rust in the winter. And the problem we're having now that we're working on is this. There is a hole, I don't know if you can see in the bottom of the generator here, and this was mounted on the shipping pallet with this bolt. It's a steel bolt. It was mounted in there and I was able to take it out, but the problem is I can't mount it in there into the concrete because I can't drill a hole in it because I can't reach it. So it looks like what you're supposed to do is you have a crane, you put it down here, or you measure it out, make the hole, and then you can fit this bolt in and bolt it into the concrete. But I didn't do that, and I don't have a crane. So what I came up with is this. From Home Depot, I got these very heavy-duty brackets, and it was in the electrical department. This is very heavy, and I'm going to mount it against this and put the bolt that came with it into the concrete, either here or there. And I got this, I think it's a 3/4 inch bolt, and I got this pressure thing to so that if it vibrates, it's not going to fall off. It's not going to loosen. And I'm pretty confident that that'll hold it into the concrete. So what I have to do is drill a hole in here, and then with the hammer drill a hole in there, and something like that, and that should be fine. So I heard you put a little oil on the drill bit, and we'll drill a hole through. I'll probably paint it so it doesn't rust, whatever I've scratched off. Okay. Wait a minute. Is it the top one or the bottom one? I think it's easier to bolt it because this is blocking it. I'll put it in the bottom. Okay, I'll work on that. I think the oil keeps it cooler so the bit doesn't get destroyed. Alright, so still have a little bit more to do. Alright, so we'll try with the hammer drill. I need it a little bit wider. Let me just put it on drill. Alright, no hammer. Okay. All right, let's see this. Let's get a brush. Maybe we'll brush that away. Actually, maybe, just see. Okay, so I painted this up just so it doesn't rust. Then measure this out to make the hole over there. And let's make a hole. Oops, okay. All right. Okay. Let me just touch up the paint here. Okay. So now, you take this bolt, take the bracket there, that there, the lock washer goes on first, the bolt goes on next. Tighten that by hand. And the... Hope it fits. Let's see. Put it on like that. And then with the ratchet, tighten it up. Okay, that's really tight. Now, for the bolt going down, switch sockets. See if it catches. Oh, that wasn't good. Oh well. Probably what hole wasn't big enough, so I'll have to make another hole over here and cut that out. All right. All right, so I think I'm just going to leave that in there. It kind of holds it a little bit, and I'll just make a second hole over here, a little bigger, so the bolt doesn't snap off. Okay. Hopefully that'll go better. So obviously it shouldn't be so tight that you can't get it in. This may be a little too tight. Let me loosen it up. But this can happen when you're doing projects, that things don't always go the way you hope they will, but still not going in. I think the hole is too small. So let me get a little bigger bit and drill it out. We'll make this a little bigger. All right, it's also deeper, so some of the dust went down, which is good. And then, let's see what we need. One of these. Okay. Okay. Okay, so after much effort and a little banging with the hammer and ratcheting it, we got it in, and now it's very solid. I mean, it's a 1,600-pound generator, so I don't think it's going anywhere, but I don't want the vibrations to shake it. So this, I'm pretty confident we'll keep it, and I'll do it for the other three, and then we'll move on. So we're back, and I finished all 4 of the L brackets, holding it in. I got a little better as time went on, and I'm done with that. So at this point I'm a little tired, so I thought we'd take a break and just look inside the generator. And one of the goals that I have is I want to try to read some of the numbers off of the belts, because off of the belts, the hoses, because the engine is a GM 4-cylinder Vortec engine that seems to be pretty common, but I can't figure out all the parts. Some of them I think are custom made for Briggs, because it seems like it's a custom case. So maybe the hoses, some of them are custom for Briggs, but whatever isn't, I'd like to figure out so I could perhaps buy it cheaper on the internet instead of having to go to Briggs. So we'll take a look at the generator. Here's the basic. I've opened it up. I've waxed it up so it won't rust. Here's the intake on the side. The other side, we'll get to that. And then here is the exhaust. I didn't open that. Let's take a look at this. Here's the exhaust. You can see the radiator is really nice. It's a aluminum radiator, automobile exhaust. So it blows out. The radiator is pushing out the air from the engine here, and then it pushes the exhaust out, and then it comes up and it goes out. Okay, so let's look around the front. And you can see this is the exhaust with a insulating sock. Here's where the battery goes. That's the alternator, pretty large alternator. You see they lower it with a hook, I guess at the assembly line. Here's the natural gas where it comes in. It goes through a Impco part, and that's getting air from the air filter, which is up there. Interestingly, I don't know if you can see this. This is, I guess, in case of a backfire, this opens up and it lets the air out of the air filter casing, so that there's no damage. Let's see if we can see up there. Not that well. Okay, so looking around, here's the alternator. Looks like an automobile alternator. And importantly, I want to get that belt. The belt number is, I can't read it, 15888. That's what it looks like to me. And then there's another number there. I can't really read it, but it's looks like maybe I, then AV0965, and it says matchmaker on it. Matchmaker. It's maybe it's 15386. Yeah, I think it's 15386 matchmaker, and then it's like maybe 11 AV0965. Okay, and you can see over here, okay, this is where, hopefully you can see, this is, you loosen this to get the belt out. I think the light in the back is affecting the picture. Let me see. Let me try to get a picture. Okay. I think that's better. And then it goes out here. Here's the upper radiator hose. And I can't see any numbers on it. So it ends in the numbers 1427. And it's like Tyco, I believe. Okay. And the upper radiator hose, oh, that's the upper one. The lower one's on the other side. It says something like 351. But this is the 4-cylinder engine. I think at the engine you could probably see better on the other side. And we'll go around the other side. Okay. But the alternator is just huge. I mean, that's what a generator is, just an engine and an alternator. And interestingly, over here, if you can see over here, right here, that's where the engine heating part goes. We're going to cut that clip and connect it there, and then one on the other side. And then an electric pump heats up the water and pumps it in a circular motion so that it heats up the engine. Let's take a look at the other side. Okay, so this is the control panel. I don't have a battery in, so there's nothing going on. But it's very similar to the 20 kilowatt generator I had. And in fact, you should really watch that video first, because this is really based upon that, because it's all the same information. I went into that in detail, which I don't really need to go into in this video because it's in the other video, the 20 kilowatt Briggs Stratton. It's all the same controller. They're Briggs. This is Briggs basic controller, so they've mounted it nicely on a stand here. Okay, let's open up this side. Here's the antifreeze bottle for coolant. Here's this lower hose, which is made by Tyco, I believe, and it says something like something 4 and then 14289 space and a 7. Tyco. See, the upper hose, it says on it PT 1485, but I haven't been able to locate that number on the internet. Okay, now I'm going to put all of the product numbers that I can figure out on the description part of the video. But let's take a look at it. Here's the starter. If this breaks, you can just probably get it rebuilt. Here's the oil filter. Here's the oil. It says over here, oil drain, which is this. Pop that out, empty it into some kind of container. I don't know how to do that, how to fit that in here. And there's the valve down there for the oil to open it up. Let's see. So it's a 4-cylinder engine, a GM Vortec, as I said, and you can see over here the spark plug wires. Here's the one you can see best. And I was thinking of going with iridium plugs, but I couldn't figure out exactly what the conversion was for this spark plug, because it's not in a car and you can't cross-reference by spark plug. If anyone can figure it out, I'd appreciate that. But in any event, I tried to figure it out, and it's kind of complicated because some spark plugs are longer than others. The thread might be longer, and that can cause unintended ignition. So I think I'm just going to stay with the stock plugs. And here's the alternate, the rotor cap, the rotor distributor. See, it's a different color. This is the electricity going in. It comes from here. Here's the coil, if I have that right. Let's see if you can see that. This is the coil, so this is and Here's a distributor. 4 of them going out, 1 coming in. That's nice. It's a nice setup. Here's the fan, plastic shroud. You can see there's nothing over here on this one. The belt goes on the inner one. Alright, here is the thermostat, I believe, for the so the computer knows the temperature of the water. And this one I think you also cut off. We're going to cut this off and connect it to this side of the hot water block heater. So I may have to drain the radiator to do that. I hope not, but I think I have to. I may have to. Alright. Unless I could remove it quickly and put it on. I don't know. Alright, here's the top of the engine. Let's see what it says. Oh, I can't focus on it. Let's see. I think it's just too close. Okay. This is the electronics, apparently. And pretty much that's it. It's really just a simple 4-cylinder cast iron engine. Very simple. Powers an alternator. Runs at 1800 RPMs, which is really why I wanted it, because it runs quiet. Nice. Everything is really nicely done in here. Nicely insulated all over. And then you have these extra metal covers here, which I'll show you when I can close it. And then over here is, interesting, 2 of them. The gas comes in over here, goes through one electric valve. You can shut that off manually if you want. Then it goes through a second electric valve, and that can be shut off manually. So they're really not taking any chances here. They really want to make sure that if for some reason the engine dies, in other words, when you start the engine, it gives electricity to these valves, these electric valves, turning them on. So if for any reason it dies, there's no more electricity going there because the engine's not producing any electricity, and it shuts it off. They just shut off naturally. So, but they're putting 2 of them in here, so they really want to make sure that that gas doesn't escape. That's really a high degree of protection, and really seems like a quality product. Impco. I'd like to figure out what those hose numbers are, but I don't know. I just don't want to take them off. But in any event, it's not the worst thing to order a hose from Briggs. But I do have the part for the oil filter, and pretty much that's it. Okay, so just to show you the door before. Okay. I'm just hopeful this will run quieter than my 20 kilowatt Briggs, which was running at 3600 RPM. It was really loud. Okay, let's take a look. Here's an example. On the engine parts, you have this metal door, which is aluminum. And then it has this door, which has this really nice rubber here to seal it in. and sound insulation over there. And that closes and latches. It has a key, but I don't really have a need for that. So I'm not going to use it. And that's Briggs & Stratton. It seems like a really good quality product that I'm really looking forward to getting started. And that's it. Okay, so I thought we would take a quick look at the block heater kit for the 35 kilowatt generator that we're going to install probably next week or so. We're calling it quits for this weekend. And let's take a quick look. We have this protection. This is not a hose, it just protects the hose from vibrations. And basically you have, it looks like you have two hoses. One for coming, there's one on each side of the, attaches to each side of the engine. And it basically seems that it pumps the hot water through this hose and it comes to the pump and then back out here, back into the engine. So both sides of the engine get this. And then the hot water gets pumped through there, through the engine to keep the engine warm and to keep the oil in a liquid form so it doesn't solidify. So the kit comes with a bunch of radiator clamps, screws to hold down the heater, and see there's basically a hose like this. One is about 3 feet, the other one's maybe a foot, if that. This wraps around the hose. And then there's a frame. This attaches to the frame. I presume like this, maybe like this. I haven't read the instructions yet. And here's the block heater. It says engine coolant heater. This heats up the radiator fluid and pumps it through the engine. It's 1,000 watts, so I mean that's an issue. 240 volts because, and 1,000 watts. It'll probably cost about 20 cents an hour to heat up the generator, and that's a lot, hour after hour actually. If it falls below, I don't know what the temperature that it probably about 40 degrees. So it's going to be heating it up. You know, it could be about a few dollars a day to heat up the generator. I may put it on a timer. I had just some crazy idea of putting it on a timer so that every time it exercises, it'll go on, and then every so often there's a blackout, it'll just go on cold. I haven't decided, but in any event, they also said that the heater keeps the humidity off the engine because the engine's warmer. So I think that's a good thing. So I probably won't. I'll probably just leave it on all the time. I don't know what side it takes it in and it pumps it up, but I don't know if that matters. But it's just a heater and a pump. And the wiring, you know, there's 3 wires. It's 240 volts, so it probably takes it off the 2 120 volt lines coming into the generator. In other words, the generator during when it has power, when the house has power, it's taking it off the fuse box to 120 volt lines, and one thing it's doing is it's monitoring them. If there's ever a blackout on one or both of them and there's no power there, it turns on the generator. The other thing that it's used for is to it's used for like the block heater. Some generators have a battery heater, and you plug all that into the 220 volt lines and you get the 240 volts, and this just hooks up. It's probably just a ground, and probably hooks up something like this. We'll figure it out. My only question is, do I really need to drain the radiator to hook this up? What I may do is just take my chances and take a hose and connect it, and then open the plug on the engine and quickly push this on with a clamp, so hopefully I won't lose too much of the radiator fluid. I don't have the energy of draining it, so maybe I can get away this way. In any event, we'll work on that more next week, and we'll take a look at that. It's 5/8 inch. Installing the heater kit, which is supposed to pump water through the engine and heat it up. So the instructions actually are really poor, but it looks to me like you connect it on this side to the flywheel cover. That's what it says. It's difficult to tell from the picture because they remove parts of the engine that making it difficult to identify what side to put it on. But I'm very confident now it's this side. This is the side where you have the exhaust. That's the exhaust. They remove the exhaust in the picture just to show you what to do. But so you take off this bolt. That just holds the battery cable, and then the other bolt underneath it also. No. Okay, remove that. Oh, remove this bolt. And then this should fit on. Okay. It's hard when you're a righty. That's tight. Okay, you got the frame on. It doesn't have to be that tight. I don't expect it really to move. Now it comes with bolts to connect the pump. I'm not sure if it's a pump or it just works on, or if it's just a heater and it works, because the hot water rises, it'll naturally float through the engine. But in any event, we'll check it out later. This fits on here nicely. And though I think I may put the hoses on. Okay, so I've decided that I've connected the hoses to the heater, and I did not attach it to the frame that I put on because I think it'll be easier for me to get the hose on without that attached. It doesn't really mention that in the instruction manual. The other thing is, I have to remove, it says cut the barb that's holding this cap, and they recommend draining the radiator before doing this because once you open it, it could leak. But I'm going to try to get it on without draining the radiator, and if I lose some, I'll just try to catch it in a container. I know it's difficult to see because it's cramped in here, but we'll do our best. Okay, let's cut this, and then we'll have to get this on right away. It's not that easy. Oh, maybe I could cut this. Okay, I think I got it. Whoa, okay, it's starting to come out. So let's get this ready. And I'm gonna take off the cap and then push this on right away. Hopefully I don't ruin my camera phone. First, let's take off the metal. If I can take that off. Got the metal off. Can you see that? Not so sure. It's over there. It's, hold on. It's above that. It's right there. Oh, you can't see it. I'm sorry. It is what it is. But we're taking that off and we're going to put this on. This I should have put on the reverse way. Hold on. It's not too bad. Hold on. Oops. Alright, let's go see. Hold on. It's not right. Like this. Okay. I could have planned that a little better. But we didn't lose too much. Because the cap is closed on top, it doesn't really drain out very quickly. Let's loosen this. I can't get it over. Okay. Okay. Now we'll get this up here and tighten it. Just gotta dry my hands from the antifreeze. Okay, it doesn't have to be that tight. It might be a little too tight, but okay, I think that's fine. Okay, let's dry this off. I have to go stop for a little more antifreeze. Of course, none of it fell in the container. None of it spilled in there. It all spilled on the bottom. Okay, so let's line this up. Now it's easier to tighten this up. Oops. Oh, so I hear it draining. Well, that's no good. Hold on. Okay, so we're back, and I'm bolting it to the frame now. I've attached it on one side, the hose going up. I didn't quite realize that the antifreeze went through the pump and then came out the other side, and we started to have a leak. So I had to lift it up higher. And when I lifted it up, it stopped leaking. So I'll have to add some antifreeze at some point. But you just have to tighten these bolts. There's a lock washer and then a regular washer. It's just a pain in the neck. There are 4 of them. I've done the ones in the back. Just, you don't have to do it so tightly because it is plastic, the pump frame. I think just snug is fine. Okay, so let's go on the other side and cut the other one and attach the hose to that one. I think we lost like a quart or so of antifreeze. Okay, so then before I go to the other side, just to show you, there are these wires. These run along the frame on the bottom, and they come with zip ties and these little pegs. So you can see it. Hold on. These little pegs, you push that into the metal frame, and the zip tie goes on top. These little zip ties. And I'll do the wiring later when I do the rest of when I wire up the generator, but it's not necessary to do that now. Okay, so we're going to do this side now, which is by the fan blade, and behind that is the fan blade. It looks large because it's up close, but this time we're going to try to do a little bit of a better job in terms of losing antifreeze, though we may have lost it, so it may not matter at this point. Let's see. I'm going to cut this metal. You know what? I think okay, got it. Now, it got in the metal. That should come off. Okay, now, hopefully being a little more prepared this time, I'm going to take this and get this on right away. Okay. Ready? Okay, that wasn't so bad. Okay. Get the clamp on. Oh. It's always good to be prepared and think this through before you do it. Hold on. It's also good to have enough paper towels so you could dry your hands. Come on. Okay, and that's it. So we've attached both hoses to the engine. We just have to do the electrical, which we'll do next time. And you can see it hooks into both sides of the engine, and then you can then it just heats it up. It just pumps the fluid through, or just through the natural rising effect of hot water, it goes through and it heats up the engine. During probably when it drops below 40 degrees. So we'll move on. So we finished with the heater block, and I thought I'd just give you a view of things of the engine again with some better lighting. I also want to try to figure out what the original equipment numbers are for as many of the parts, replacement parts, as possible, so I don't have to order them from Briggs Stratton. I can order them from Amazon or or whatnot. We've already figured out much of them. The oil filter, spark plugs, and the alternator belt. But there's a few more that I haven't figured out. So I thought that I would just try to remove the clamp from the radiator hose. I'm not sure if they're both the same radiator hose. I'd like to try to figure that out, and we'll see what we have. And just to give you a view of the engine on this side, let me see if you can get a better view. I don't know, it's hard with this lighting. In any event, that's another piece I wanted to show you. I think that's the computer controlled throttle. Up, right there. Right there. It's all covered, which is nice. So I'm going to open up that clamp and try to get the label off. It says like Tyco on it, but when I tried calling Tyco, they say sell like burglar alarm equipment and stuff and electronics. They didn't know anything about the belt. So let me see what I can come up with. Okay, I took the clamps off both radiator hoses. And first, just to note, the radiator is made by Radiator Specialties. It's an RS-676. I'm sorry, RS-6756. Okay, so we know what that is. Okay, so as far as the radiator hoses, the top hose, still sunny. It's Dayco Flex Hose 81171, and the UPC code is as much as you can make out, 38244. I don't know, maybe 7427. This digit a 1, and then a 2 at the end, and that's the top hose. The bottom hose is a Dayco 81351. And its code is, that's easy to see. I don't know what this PT1485 means, but it didn't mean anything on the internet. But at least we also have the, there's a top hose, it's, what does it say, 1.5 ID, internal diameter by 17.25, and the other one is 1.7 ID. The bottom hose is longer. It's by 23.5. Okay. Now the only other part that I'm glad I have the hose parts. If I can just order them if I need them from Amazon, it's a lot easier than ordering from Briggs, and probably a lot cheaper. So let's try to see if we can figure out what the air filter code is. Let me get some light. All right. So here's a better view of the engine. I have some more lighting. It's hot. Okay, so here's the battery cables. So let's see what we can accomplish with the air filter. So that's the air filter cover. There's some clips. There's one on top. Why would they put one on top? Go figure. Alright, does this come off? Okay. Great. The air filter, how does that come out? You know what, maybe I don't need to take it out. I'll leave it. It's a long air filter. And it's a Donaldson. Part number P532410. I know you could read. Let's make sure we get all the numbers. AU1379. Okay, so it's an air filter, so now I could probably figure out how to get that on the internet without having to go to Briggs. So we'll close that out. The alternator. Now we're working on the electrical part of the generator. I got this connector. It's a pretty big connector. I think it's 2.5 inches. And it's waterproof. It has this piece and this piece which goes around the tube. And it's a waterproof seal. So you keep the water out. And to connect to that, I got this conduit. It's a flexible conduit, 2.5 inches. It's global manufacturing type EF. Metal inside, I guess aluminum, the thick plastic sheeting. That's gonna go over here. And the other side will go into the wall. This will attach to this. Something like that. The connector will go on first. It'll lock into place onto there with a waterproof seal. This piece actually cost me $75. I was actually surprised. I mean, it's a heavy piece with some seals, but it seemed like a lot of money. And pretty much that's all I needed, though. I had to Dremel out a bigger hole here, which was difficult because it's like 1/4 of an inch thick of steel, this part. Very solid. But it's done. I've got the connection, and we'll move forward. As the wiring is concerned, we have 3 types of wire that I'm using. The first type of wire is the, let me show you this first. There's basically 2 wires that come off the transfer switch and go to the generator. They're connected to the 2 hot wires coming into the house. And they're fused, and then they're connected to 2 wires that go to the generator, so that the generator knows if one or both of those lines loses power, it knows that the house has lost power, and then it should turn on the generator. So the book, Briggs Stratton book, recommended that I use 14 gauge wiring. I wasn't that comfortable with that, so I ordered 12 gauge. It's just 2 hot wires, as you can see. It says it's 600 volt wires. I'd rather use 12 gauge than 14 gauge. I'm not so comfortable with 14 gauge. And what this also does is this wiring brings 240 volts into the generator, as I said, to tell whether there's power to the generator. And also it's used for the water block heater. It's used for that, and to charge the battery. So you can see that. The next bunch of wires are the control wires. Now you need at least, the minimum you need are 2 control wires for the transfer switch to communicate with the generator. In this case, it says it's 18 gauge. I also, as you can see, this is it. Like the other wires, it has this nice waterproof covering, which is really good, and so it's very durable. So I was saying is you need at least 2 wires. It's 18 gauge, so it's 18 gauge with 6 wires I ordered, so I could have 2 for the communication with the transfer switch, which is required, and then another 2 I want the optional LED light, which tells you whether there's a generator error or if everything's okay in the house. So you need another 2 for that, and the other 2 I'm going to see if I could hook up something else. I may not use them at all, or there's an option, if there's a error on the generator, you can hook this up to a horn and it'll make a noise, or I may use it for some kind of notification system. So when the generator turns on and off, it'll send me a notification. We'll see if I can accomplish that. Now these are the control wires. They're basically communicating with the transfer switch, especially the 2 that I mentioned. So I got not just the waterproof wiring, but I got this shielded cable, which is basically just tinfoil around the wires, which keeps any electricity, if it's in contact with the high voltage wires, you're not going to get any bleed from the high voltage into here, where you would get noise, and it might affect the communication between the transfer switch and the generator on these control wires. It might introduce noise that might mess it up. But I've never actually had that problem on my 20 kilowatt generator, but I don't want to have a problem on the 35 kilowatt generator, and because it really doesn't cost much more, I got that as well. And for the main wires, I got this. It's really heavy. It's 2-gauge wire. Let's see if I could show this to you. Hold on. This is heavy. It's, as you can see, 2-gauge wire, 3 hot wires. So it's basically 2 hots, a neutral, and then a ground. The ground is not shielded because it doesn't need to be. You just have to shield the 2 power lines and the neutral line, and then the ground doesn't have to be shielded. That's connected. This wire is connected between the generator and the transfer switch. So this is basically transporting the 35 kilowatts of electricity. I mean, the only issue I see is they're not colored, so I'd probably have to figure out which one's which with a toner, or I'll just send some electricity down. And you can see also that it's covered with this thick waterproof covering, which is good. It keeps the water out, but we're anyway going to put this in conduit, as you'll see. But I have to tell you, this is really heavy wire. I mean, it's fighting me just unbending it a little bit. And I'll put all the details on the description part of the video. But you can see that here. Let me see if I can zoom in on it. It's 2-gauge. It says 600 volts. 2/0 AWG THHN, and then something else, something with ground. Sun resistant, direct burial. You could bury this directly into the ground. And just to show you on the 12-gauge wire, that's what it says. And then on the 18-gauge wire, these are also direct burial. Can handle 600 volts. But going back to the main cable, just to show you what that looks like. If you look at my other video, you'll see the wiring for the 20 kilowatt generator. That used number 6 wire, and that was like a half of this. And I'll show you, it comes in a roll. This is about 55 feet. It weighs about 120 pounds, I believe. Yeah. Comes in this nice roll. A very good wiring company. I'll put in the description. They ship promptly, and everything's in great shape. So the next step is we're going to roll this out, and I'm going to zip tie it together to be one line. So at least during installation I could pull it across and get this done. So the next step will probably, after we do the wiring, will be the transfer switch. And I can show you the difference between the old one and the new one. Briggs said I needed a transfer switch for the water-cooled generator, that it's different from the air-cooled generator. I don't really believe them, but I got one anyway because I needed the old one for the old generator. It's going with it to another happy home. So I'll give you a quick shot of the old transfer switch and the new transfer switch. First, we've disconnected the old wiring. As you can see, this was 6-gauge wiring. Much thinner, and nothing like the 2-gauge wiring. In any event, Let me give you a quick view. Here's the old transfer switch. It looks exactly the same. It's very similar. Get some light. There's that circuit board. It just kind of like fell off. I have to tighten that up. And you can see here, there's the main shutoff there. And then there's that's where the generator power goes to on top. It connects on top. And there's a special circuit for that, a fuse for that. And that goes down into the, it's connected over there to this part of it. And it all goes down out back to the circuit, to the main fuse box. And this over here that you're looking at is the actual switch. And it switches between utility and operator power. It's hard to show you because I'm holding the light and the camera. That's a circuit board. Now, just note that extra shutoff. There's also a circuit breaker on the generator, so there really isn't a need for that, but it's nice to have it here, and I'll show you that as compared to the new transfer switch. Now, the new transfer switch, as you can see, it's very similar. It's almost exactly the same. In fact, I think the circuit board is exactly the same, but for some reason, Briggs said that I need a new transfer switch. There's one especially for water-cooled generators. Now, if you look on the outside of the new transfer switch, this box, it says, okay, that's good advice. And here, they don't have that separate, the additional circuit over here cutting off the generator power. They rely on the one in the generator. They do, you see, it's empty over here. They do sell that as a kit. You can add that on if that's required in your area. You can add that on, but you have to pay extra for that. And just to show you in general, it's the same. Let me get some light. It's the same circuit board. Now this circuit board there's a few things here. One, you can shut off, I can't get a good view. Hold on. Board has over here, a normally closed circuit over there. It says 5-ton there. That'll go to my 5-ton air conditioner. Even though it's not really necessary, the system has enough power to power everything. But that basically disconnects when the generator first goes on, so that, and then it'll turn it on if there's enough power to do it. Basically, I have it so that I want the air conditioner shut off a couple of minutes before it turns on, so that it'll relieve the pressure in the compressor of the compressed fluid. So sometimes there's a problem if a compressor turns off and on. And here, just ignore the wiring for now, but basically you connect the two control wires over there from the generator. This circuit also, there'll be these, I'll show you on the old circuit board over here. This measures the current from the generator, and if that current is more than what the dip switches are set to, these dip switches tell the circuit board how big the generator is. If the current is more, it'll trigger an error and shut off the generator. Also, what this does is, you can see it gets power. Let me see if you can see. It gets power both from the utility and from the generator. And the purpose is basically, when there's a blackout, this is actually dead. This whole circuit board is dead. And it only powers on when the generator turns on. So that's the first thing that turns on. The generator sees it's connected over here to these two utility lines. And when the generator sees that there's no power coming in from the utility, it turns on, sends power here, powers up the circuit board. The circuit board says, oh, there's no power, checks out the voltage coming in. If everything's okay, it flips this switch over here. If you can see in here, utility to generator, generator to utility. Here's the main shutoff, and that's pretty much it. The only addition on this one is the Symphony board. And I don't know what that is on that big box. It looks like some kind of communication device. Basically, this is hooked into the circuit board, and then with this extra board, you can add a box outside with relays that can connect to your air conditioner, so that this can control outside air conditioner, so that when the generator first turns on, it can shut off as many air conditioners outside as you want, and then it'll power them up one by one and check out the load to see whether the generator's there's too much being asked of the generator. That's called the Symphony control board. Just a little board. That's the only addition this has over the other transfer switch. I got this switch because Briggs said I needed it. But it's really pretty simple. It's the neutral. That's the ground. Just push it in, or you latch it. You open up. Okay, that's it. Kind of latches in. Yeah. That's cool. Well, it's not running because there's nothing on, right? We shut it off from the inside. Mm-hmm. So there's no power drawing. Okay. And how do you put the cover back on? Slips up. That's the whole thing? That's it. So the electrician came and he finished installing the transfer switch. So I thought I'd show you it briefly. It's, as I showed you before, it is very similar to the other transfer switch, the air-cooled, for the air-cooled generators. This is for the liquid-cooled generators. And I'll just give you a brief view of it. This is the this is a wood stick. So these are the power lines coming in from the meter. They go in there, and these are the power lines going in from the generator. These magnets are measuring the electricity. They basically they measure the magnetic field created as more electricity passes through. It's a stronger magnetic field, and that goes up to, it basically I think turns it into electricity. It steals electrons basically, and then that goes into the circuit board. It's difficult to see, but it basically gets plugged into the circuit board. And behind here, over there, these lines go back into the main panel of the house, which is this. So the transfer switch chooses, is the power going to come from the generator wires or from the utility lines, and then it gets transferred back into the box. Okay, so now it's on utility, and I did notice, as I told you, this is a heftier transfer switch, and if you notice, one thing I noticed is there's a little switch over here, if you can see, where after this switch, this utility switches down to generator, there's a little switch there that tells the circuit board whether this switch is actually, what position it's in. If you look over there, this basically makes contact. There's a little piece of metal there. That makes contact with the switch, and it tells the transfer switch that it's successfully shifted from one to the other and what position it's in. One thing I did notice is the reason why we did have to change the transfer switch. I believe it's really all this very similar. I think this circuit board is exactly the same as the air-cooled generator circuit board. I believe that to be true. But what I noticed was this: where the generator wires come in. Remember, on the other one there was a separate circuit here, but on this one, basically, you see this over here. This is accepting 2-gauge wiring. On the air-cooled generators, it wouldn't accept 2-gauge wiring. It wasn't big enough. It would only take the 6-gauge wire that was coming in from the generator. But this 35 kilowatt generator requires 2-gauge wiring. So this is much heftier on this transfer switch. this connection on the air-cooled transfer switch would not accommodate 2-gauge wiring. So that's it. Otherwise, it's pretty much the same. The circuit board just requires over here, let me see, let me just focus on that for you. Just requires 2 wires here. Let me see, over there, 2 wires, and that's the sole communication between the transfer switch and the circuit board that connects the 2 computers. Here's the 2 120 volt circuits. It's fused. I have, by the way, I have extra fuses, and that sends it over to the generator to run the block heater and also to charge the battery. And anything else here? This is the Symphony board, which I'm never going to use because the generator is large enough to handle everything. I don't need to. Basically, what I've done is I've used over here, if you look over there, it's hard to see, and I don't want to stick my hands in here, but basically over there, over here, this is just a simple relay. It shuts off my 5-ton unit just to give it a chance to let the pressure out before it restarts. I have a second unit that's 3.5 tons, but I haven't had a problem with that, and I think even this is unnecessary, but I have it, so I connected one of the units here, and to shut off when the transfer switch initially turns on. It shuts it off for about 5 minutes. Here's a Symphony board in which you can remotely attach some other boxes outside by your air conditioners to shut them off remotely. I noticed over here, there's a little green light there. It's right there. Let's see if we can get it's hard to get a good picture of it, but it's just a little LED. It looks like it's looking for something. Probably the boxes outside that don't exist, but it's probably just sending out a signal. Well, the good news is, you see the green lights for utility and the red lights for generator. So the circuit board seems to be working. It says utilities on. That's good news. And otherwise, we're done on this end, and we'll have to do the electrical on the other end. You can see these cables are just freaking huge. I mean, this 2-gauge wiring here. The electrician cut holes in this box to fit in these connectors. And this is one I picked out, we used. It's got a nice rubber bushing in it, so the wires don't rub against it. And here's the ground. Pretty much that's it. Alright, so we'll go outside and we'll see what has to be done there. Let's go, and we got to choose the battery. I buy it at Costco because if there's a problem I could always return it. Let's see, what we're looking for is this one. 850259, 850 cold cranking amps. Seems like a good price. Alright, so we got it loaded. Looks like it has a 42-month, they'll replace it. I think it's a 60-month, to some extent, you get a warranty. Back from Costco, we got the battery. I'm really happy with this one. It's 850 cold cranking amps, and I think it says 1,000 amps at, yeah, it's 1,000 amps at 32 degrees. Oh, sorry. Okay, so it's a good battery. This is actually a little larger than what Briggs says you can put into the generator. And I don't know why they limit it, but I did take a ruler, I measured it, and this should fit. We'll find out. The other thing I learned is that not only do you pay $90 for the battery, which I think is a good deal for this battery, Costco usually has the best prices, but you also have to pay a $10 core fee and a $5 New York State deposit. I mean, there's no end to this stuff. So, so I'm actually looking if I can find an old battery to return, but I don't have one. So what we'll do now is, this actually looks pretty fresh. It says October 2015 it was made. It's November 2015, so it's pretty fresh. So what we'll do is, we'll just charge it up in the meantime, and we'll see what happens with that. So we'll put this right here, and take off the negative, put the negative on here. Positive and the negative. Let's see what the battery tender plus says. Let's plug it in. Alright, so it's a solid red. Alright, I think that just means it's charging. Let's see. It says on the back. Okay, so it's charging. It's not even 80% charged, because then it would be blinking green, or steady green would be fully charged. So it obviously has a way to go, and we'll just leave it there and let it charge for a day or two. And the electrician came and he did his job. We don't have the gas hooked up yet, but I just want to point out, whenever you have this hooked up, you really need to get a good licensed electrician, someone who knows what he's doing, because we're really dealing with high voltage. You're dealing with the main power coming into the house, and you need someone who is really an expert in that. So it really pays to just spend the money, get the good people in, people who are licensed, insured, and who know what they're doing. I really believe in that. Okay, so going back, here's where we are. We hooked up this pipe to the watertight connection. And I know I did mess it up there. I dremeled out a little too much. I'm going to caulk that up there. But it doesn't even matter if water goes in there, it'll just roll down the bottom. Okay, but otherwise it's a waterproof connection. And that's going to be concreted up or caulked up. We'll deal with that later. So what the electrician did is he took out this plate, and with hydraulic press, he punched out a hole and ran the wiring up through the bottom. If you notice, there's no bottom here really. It's the concrete pad, so it's kind of exposed. And I'm thinking of at least caulking around here at the bottom, just to keep the water from going down, but not caulking in the front so it'll run out if any gets in. Okay, so here's where we are. We'll start off on top. This is the generator side. This is what the generator, don't worry, it's not live. This is what the generator is producing. 2 hots. There's the neutral over here, and this is the ground. And I can touch it. There's no battery in there, and there's no fuse, there's nothing. It's dead, except for one area, which I'll show you. But so 2 hots, the neutral, here's the ground, and going into the house, here's the 2 hots. They're dead. These 2 hots. And that goes in here, into the cable, into the house. Now, the control wires are over here. Let me just show you here. Basically, the minimum number of wires you need to actually control the generator is just 2. The red and the black. TXRX and TXRX ground. If you want the optional, which I have, the LED in your basement, just to show you if there are any errors, you put another 2 wires. It's optional. LED, it says plus LED, and this is, you have to really, I forgot the word, but you have to make sure you have the correct ones. You're not going to damage anything, but it won't work otherwise. Positive LED and ground, and that's going to match up with the LED bulb, which has 2 wires. One of them is going to be positive, one's going to be a ground. If you reverse them, it won't work. So that's it. So you really only need 2. If you want the other LED, the LED bulb, the option, that's another 2. And I put in a 6-wire, so I have 2 extra wires coming out here, and that's for some other project that I'm thinking about. Also over here, coming in from the house, is the what could be 14 gauge, what I've chosen to be 12 gauge wires. And those go through the 2 bus fuses. And that goes into the generator to charge the battery and run the optional block heater. Now the block heater is over here. You see these 2 black wires? That's hot, so because that's getting 120 right off the circuit board, right off the transfer switch. And what that does is, if any of these 2 wires, the red and the black, lose power, the generator is going to know, or both of them lose power, the generator is going to know that there's no power in the house, and it's going to do its startup sequence. So if it was all connected and I disconnected one of those wires, it would start up thinking there's a blackout. So that's hot from the house. And those 2 black wires there, those are connecting to the block heater. It's a 240 volt block heater, and there's a ground wire that you install over here. You see the green? Right here. That is the ground wire for the block heater. It hooks onto the ground wire of the generator. And here's the ground that goes into the house. That's connected to the transfer switch. So it's pretty straightforward, and that's really why I like the Briggs Stratton generators. It's really pretty simple. I don't know if other generators are as simple, but I'm already familiar with this one, so it pays to stick to what you know. Now up on top is the computer, which we'll take a look at later when we get it set up. I'm not going to take this one apart. If you want to see what's inside, you can watch the video on my 20 kilowatt generator, because it's exactly the same computer and the wiring is exactly the same. So if you watch that video, I take it apart, I show you there are 2 circuit boards, one for charging, looks like one for charging the battery, and one for checking the voltages and running the steeper motor and just monitoring things. So I'm not going to open it up here. You could watch that video and you'll see it. Okay, so we're pretty much ready. We're just waiting for the plumber to come, and as soon as he gets that done, we'll be able to start it up. Okay, so the next step that we did was, I noticed when it was raining that if you see this concrete is pitched, the water flows right into the generator. And the problem is, this generator does not have a bottom to it. So if you look at it, I'll show you here, you can see it's just the concrete. And although I guess it's not a problem, it's kind of like your car. You can see some parts are starting to rust a little bit, the black pipe. I don't think that's really a problem, but I wanted to keep some of the water out. So I caulked from this side. I was able to get from the inside only, but I was able to caulk so the water won't flood in here. And then on this side, I caulked all around it here, and then I really couldn't reach this side, but I don't think that matters because there's a metal plate at the bottom. I don't know if you can see it. So pretty much, at least if the water rushing through here is just gonna be stopped there, go around it. I mean, I know the concrete's gonna get wet and bring in the humidity, but at least you won't have all the water coming in. Less is better. And I don't know if you could build the concrete so that it slopes down on both sides. I don't think it would be flat, but it's just an idea. In any event, so we're waiting for the plumber. He came to look, and we had some plumbing issues here. The first is we have over here a 1-inch pipe, and we need, according to the manual, running natural gas. I don't think we'll ever hit more than half load, but we need 282,000 BTUs, and at full load 458,000 BTUs. That's not such a problem. The bigger problem is this. It says the port should be between 7 to 11 inches of water column pressure. That's with nothing else running. So the thing is this, he came and I would suggest you do this before you buy your generator, but I did not. And the thing is this, we have a meter that's about 25 feet from the gas main. And this house was built in 1912. My guess is there was no gas when the house was built. And the main was probably added in the 20s. So it's approaching about 100 years old, and it's a low pressure main. And that's not what you want. You want the high pressure main on your block, where it's high pressure, and then you could use a regulator to dial it down. You bring it down to, like, let's say 9 inches of water column pressure. But we're stuck with this main, and although I'll call the gas company, see if they'll do something for me, I really doubt that they will. I don't think they can. I don't think they're going to put in a new gas main for me. But so we're doing a couple of things. So first of all, we measured the water column pressure here, and with nothing on, it's 6.2. Okay, so that's below the 7 to 11 inches of water column pressure. We're at 6.2. When I went down and I turned on all the gas appliances and the boiler, it went down to 6. And for about a second or about 2 seconds, when the boiler fired, it dropped to 5.8. And then it went up to 6. It was pretty much all the time 6, or with nothing on, 6.2. So that's below this. I'm hoping that it'll work. Now, from what I see, there's no sensor on the generator to measure the incoming pressure. I think the Generex do, and they'll give you a fault if it's below that pressure. But so there's none of that. I don't think I'll get an error, and hopefully it'll be enough gas. But here's what we're doing. So basically, the meter is about 25 feet from the gas main, and that's a straight run. And then from here to the meter, it's about 30 feet, and there's 4 elbows. So every elbow adds about 5 feet. So it's the equivalent of about 50 feet from the meter. So 1-inch pipe is not going to do it. So what we're going to do is we're going to replace this 30 feet of pipe with 1.5-inch pipe. He's going to use galvanized, and the 1.5-inch pipe, I look at the numbers, should provide us with this, even at full load, 458,000 BTUs. Now I looked at our gas meter, and I had contacted the gas company, and they replaced that previously when I had gotten my 20 kilowatt generator, and they put in one with I think it's a 640,000 BTU gas meter. Now you can see it's going to get a little crowded out if I'm ever running this at full load with 458,000 BTUs here, and the boiler at another 210,000 BTUs, and maybe the oven. I don't think. I mean, the truth is, the boiler rarely runs at full blast. It's usually running only at partial under energy saving mode. It's a really energy efficient model, so I think we'll be okay. And I'm hopeful that with the 1.5-inch pipe, that it'll have like a reservoir of gas. So even if the boiler kicks on or the oven goes on, there'll still be enough gas in the pipe to keep the pressure up to the 6 inches, or at least the 6 inches, if not the 6.2 inches of water column pressure. I think with 6 inches of water column pressure, we're pretty close to the 7 to 11 that they say should be there, and I think we'll be okay. I hope so, or else we'll have a pretty expensive paperweight, or else we'll have to put in a propane tank, which I really do not want to do. I really want to run this off natural gas because it's here and it's easy and it never has to be refilled. Okay, so that's where we are, and the plumber will come on Tuesday, and we'll take it from there. Okay, so it's just been raining, and I'm going to check to see if the caulking around the generator helped keep it dry. You can see the water is there around the generator. This is water, so let's open it up. It's dark, but I don't know if you can see, it's totally dry inside. Look at that. Soaking outside, water pooling up over here. But the caulking here and over there on that side, I don't know if you could see it. Let's see if I can open it up, but totally dry. take a look over here. Okay, you see? Little water in the corner there. Just a little humidity. Must have come through somewhere. I'm not quite sure. Maybe it came in from up there. It may have come in from the side, but otherwise it's completely dry. A little water in the front. Very little. But keeping the generator dry. I don't know why everyone doesn't do this. Yep. It's all dry. I called the gas company and I asked, I finally found the right person. I asked them if they could put a high pressure line to my house, and they basically laughed at me. They said, look, we're not putting a high pressure line just for you. That's not what we do. It's basically, it's too expensive, and forget about it. So he said that, he just explained to me, he said that the low pressure lines are between 4 and 7 inches of water column pressure. And basically that's all I'm entitled to, that's all I'm getting, which kind of makes sense because I'm getting, I would guess that the main is probably about 7. I'm getting at the generator, when I first tested, I told you it was about 6.2. I haven't tested it with the new pipe, which I'll show you, but my guess is probably about 6.2, and the benefit would be that it's probably about the same. Maybe it goes up to 6.5. I don't know if that affects the that pressure, but I think the main thing is it won't drop because the pipe is much bigger, so it shouldn't drop when there's demand from the boiler or the oven. So I'll show you what it is. Here's the meter. Now the meter is about 25 feet from the gas main, which I said is a low pressure main, and then the plumber came and he hooked up, instead of doing the 1.5 inches, actually, this is, if you can see, it comes in, it's 1.5 inches, and then it goes into the meter, and it goes through the meter, and it comes up, and what he did was, it's 1.5 inches, he brought it up to actually 2 inches. So then he ran a 2-inch pipe directly to the generator, so that this holds a lot of gas itself, so even if there's a drop in pressure from other demand, it shouldn't, we shouldn't lose much pressure. There's a shutoff valve. I'll give you a look at that. There's a takeoff for the boiler and the oven and the barbecue. It's a 1-inch. A big shutoff valve. And then it goes outside. The gas pipe then goes from the gas meter outside, and it's about, with all the bends, and it's about 30 or so feet from the meter. I'll show you. It goes over here, big 2-inch gas pipe, and then right by the generator it goes down to a 1-inch. There's a valve here, a 1-inch shutoff valve. There's this little trap here for dust. And okay, and so you have the condensate trap, which is it's all 1-inch, and then it goes here all the way across into this pipe that came with the generator. It's a flex pipe, rubber, so maybe covered over metal, I'm not sure, some mesh, but it's, and that goes right into the generator. I can't show you, and that, well, we'll open it up, but it goes into those electric gas valves. What happened was, we have, first of all, we had the best plumber. If you want his information, you could look up my videos on the water filter installation in the house. I have all his information there. He'll give you, he's on Long Island, and he'll give you a discount if you use him and you tell him you've seen the videos on YouTube. And he actually did a pressure test. He was required to write up a report. He did a whole, I don't know exactly, I wasn't here, but he apparently attached a gauge to it, put it under pressure, and waited a long time, and then came back, and there was no loss of pressure or so. So that was fine. It passed. So okay, so what he did was I told him to purge it out as much as he could to about here, but there actually is about 5 feet of pipe inside, and then another few feet of gauges and everything, and valves till it gets to the engine. I'd like to at least try to purge that if I can in some way. I'm not sure how. With a way to purge the lines here, and what I've basically done is, I'll show you. I'm just sending 12 volts. I read the schematics, and it's basically a 12 volt circuit to those gas valves. Now if you look here closely, there is some kind of switch here that probably will let you open it up and let the gas pass through, but I'm afraid to open that because I don't really know how that operates and whether that'll break it or whatnot. I didn't really want to start up with that. So I read the schematics, and it says it's just a 12 volt circuit. So we'll send 12 volts to the 2 valves, let the gas flow go through, purge out all the air, and then when we start it, we don't have to beat up the starter. Now interestingly, when I looked at the pipe, I realized that they actually reduce it from the 1 inch coming in all the way down to 3/4 of an inch. And then the gas pipe that goes all the way around is all just 3/4 of an inch. So hopefully there should be enough gas, I hope, coming into this thing, because it's only coming down to a 3/4 inch pipe. So let's see if I can purge this. Try to give you a good view. Maybe I can get you some lighting. Hold on. Okay. Okay. So I'm going to connect this to the battery, and we'll see what happens. Okay, you hear it going. I'm trying to see if I hear the gas. Yep, the gas is flowing. I don't smell anything. Actually, I smell a little bit. But it's okay, you can't flood an engine with natural gas, which is part of the reason why it's better than gasoline, because gasoline will become a liquid and flood the spark plugs. But natural gas won't. If it's too rich, it'll just breathe it out at the exhaust cycle of the engine, and then breathe in the correct amount on the next cycle. Okay, so I smell it. That's enough. And I think right now it's the gas is all the way in the engine, so it should start up pretty quickly without grinding up the starter. Okay, so while that's airing out, I don't smell any gas anymore, but we'll let it air out a little more. And I think what you need to do before you start any engine is you want to first check the hose. First check the belt. Just push it and see whether it's taut. And it is. You want to check the hoses. We've already checked the hoses, but you definitely want to take a second look at those, make sure everything's okay. 2 things we have to do is, first of all, you always want to check the oil. Always. Double check it, triple check it. Be paranoid about your oil. Don't rely on the engine's low oil cutoff. You can't rely on anything. You just have to check the oil. And then, of course, we have to add some radiator fluid because we spilled some. Okay, so let's check the oil. It's right over there. Okay, pull it out. And I don't know if you can see it. It's full. Hold on. I'll try to get a better view. It is full. So the oil is good. And we'll add some radiator fluid. First of all, the oil that they give you is not synthetic. This is real, I guess, for the break-in. But it's interesting. You don't have to change it for the first 100 hours of use, and then you change your oil every 100 hours after that. It did smell good and clean, and that was good. The other thing I do is I do take these some rear earth magnets. Take some like this. I gotten some from Harbor Freight. This was 99 cents. And I put them on the oil filter. And I do that because it magnetizes the oil filter, and any small fine metal particles that go through the oil will stick to the oil filter. In other words, if it's too small to be filtered, it would ordinarily go through, but this will let it stick to the metal oil filter. It's really another form of magnetic filtration. So I put this at the bottom. If you can reach it, it's sticking to everything. I'll put this actually on top. It wants to go elsewhere because it's so magnetic. And these other magnets I'll just stick on the bottom. So it's pretty well covered with magnets. Okay, now we have to add the antifreeze. I got this antifreeze. It says Prestone, it says Dex Cool. Now, this is antifreeze. It says do not add water. It's already pre-mixed. When I was younger, we used to laugh at people who bought this stuff because you would just pour one in and then fill it up with the garden hose and pour that in. That was the 50-50 mix. But this generator says it needs, it can't use water from the sink. It has to be distilled, and honestly, I don't know where to get distilled water. So this doesn't say it's distilled. It says it's already pre-mixed. I presume it's distilled water. But in any event, it said GM on it, so I felt comfortable. It was a GM engine. They probably know what they need. But of course, Prestone makes it. If I need a bunch of containers of this, I probably would call them up and ask them if the regular Prestone is the same. Okay, we'll add that. We'll fill it up all the way so the engine will just suck it in. Okay, a little less than full. Okay, so we're going to put the battery in, and let's pull this away. I want you to strap it down. So I don't know how they expect you to get the strap in here. It's kind of ridiculous. Alright. Oh, but let's put this here. Battery goes in. Move it over there. Okay, it's a little too short, so let's take another one. Hmm. All right, that's pretty tight. Okay. All right. I think it's. I'll keep it from vibrating. Okay. Cut that. Always put the positive on first, and then you put the negative on. And when you take it off, you always take the negative off first, and then the positive. You have to loosen that. Okay, that looks good. Does that go down all the way? Pretty much. Okay, we'll tighten it up. And just... Okay. Doesn't have to be that tight. That's good. Okay, cover on. Oh wait, before we do that, let's tighten up the other one. All right, that's tight. I always put a little grease on there. I think it just keeps the humidity off, the moisture. Just a little. cover it up. If you see, there are two wires here. One's a thick wire that brings the battery power to the starter and to the computer, and then there's a small little wire which probably is the charger, the 12 volts coming in from the computer to keep the battery charged. Does this have a cover? The negative does not have a cover. So we have the battery in, and nothing's here. Let's see. Take that off. Nothing there. Okay, we need we need a fuse. Where's that? So it comes with these two 15-amp fuses. So I'm gonna put one in. Oh. Okay. Then I'll just put the other one in here. 240 volts, single, 35 kilowatt. SWC 7.0. That must be the ATS controller. That must be the programming thing. Present. ATS controller is present. That's good. Okay, so can you see that? Hold on. All right, let's do that one more time. Hold on. Can't get this in. All right. Let's see what it says. Nothing. Okay. Now it says nothing. That's not good. Let's figure that out. Okay. And I won't say that menu again, but runtime is 2 hours. I guess they ran it in the factory. Oh, 0.2 hours, so that's not much time. Date, November 20th. Oh, it has the date. That's good. It keeps the date. That's great. It must have run like 10 minutes. It's 2 p.m. Oh, it's daylight saving. It doesn't keep daylight savings time. So let's go into the menu. Let's take a look at it. Exercise cycle Tuesday 2 o'clock. Exercise cycle. All right, let's go into the menu. The basic menu is you hold down both. Hold on. Let's see. Tuesday. Let's see. Date. November. Okay, that's right. See, it's 1:03 p.m. Oh, that's good. Let's see. Tuesday, 2 o'clock. Let's see that. Let's see. Let's hold this down. I'll play with it. Alright, I got into the menu. You just have to hold it down. Set date. That was fine. Set time. Hours. It's 1 o'clock. Minutes. By 1:05 p.m. Set exercise. Okay. Now I want it Wednesday. We'll do it at 2 hours. What is that? 2? I don't know what that means. 6, 7, 8, 9. I think it means 11. I'll do Wednesday at 11 o'clock. It doesn't keep track of daylight savings time, so it'll fall back to about 10. 11 minutes. 11 PM. No, AM. AM. Show events, logs. Okay. Service code at October 4th. That's probably when it was born. Okay. Okay, let's exit that. Now, there's a way to get into the more advanced menu by holding down all three buttons. I think it's menu and both arrows. Oh, I let go. Alright, it's not letting me get into that more advanced menu, but I'm not so worried because it did say that it was 35 kilowatts. I think it's at 240 volts. So that's really what I was looking for, just to verify that. Alright, let's hit it off. See, we can put it in auto mode. Let's see what happens there. Generator ready. Okay, that's a good sign. So it means that it's saying hello, it's handshaking with the transfer switch. And it's saying, okay, so far so good. So I think we can just about start it. Huh. Okay. And then we'll check the voltages. Now the voltage, I'd like to run it with the switch off just to make sure everything's okay. The only thing that's hot at this time is the those fuses that you see in front of you, because those come from in the house. So I got into advanced settings. It says advanced settings, and to get into advanced settings you actually have to hold down the two arrows and the escape. So it's just saying advanced settings. Let's see what's, can you see that? It's a little, okay, let's hit one. 35 kilowatts. That's good. That's, my other generator wasn't programmed correctly. So I'm just checking it over here. You could watch that video and I explain it. 35 kilowatts. That's good. 60 hertz. That's good. You want to make sure it's 60 hertz because some of them they sell at 50 hertz. Single phase. That's what's important. Oops, sorry. 240 volts, that's great. CAN bus test. I think that tests basically the, it runs a test, I think, on the valve that lets the fuel into the generator. I think that's one of the tests. I don't know if that's CAN bus. I don't know, but I don't think there's any need to test anything. Alright, so let's go next. Software. C.700. I don't know if you can see that. Yeah, back, maybe you can see it. This was the CAN bus test. I don't know. Okay. Software, advanced setting. Okay, so let's exit out. Okay. So I think what we'll do is we'll try to manually start it, see what happens. And then I'm going to check the voltages. What I'm going to do is I'm going to try start in manual with the fuse off. I don't know if that's going to give me an error because the transfer switch is not going to see any voltage, but it's in manual mode. If it doesn't give me an error, I think what that means is the generator doesn't really get any feedback from the transfer switch in manual mode. That would mean that you could actually hook this up to a manual transfer switch, and then it would work if you didn't want an automatic one. So we will check the voltage. Let me get my multimeter out. Okay, I don't know if you could see it. That's the problem. Alright, so just to show you, I have my Fluke multimeter out, and I'd like you to see it. I don't know how. All right, can you see that? Okay, I'm just going to test right over here, show you. This is hot. These two. Open lead. That's not good. I said open lead. Let me take a look at that. Okay, so it was just a setting on my multimeter, but here, when I touch these two, you can see it's 243 volts. 243.4 volts. That's actually coming in from the house. So that's the utility power. So it seems a tad high, but that's the utility, so you can't really... It's usually within that range, in the 240s. The rest is all dead. So I think what we'll do is we'll start it up, and we want to measure the voltage before I send it into the house. Now, the transfer switch is off anyway, so it's not really sending it into the house. It's really just sending it to the transfer switch, but I want to check everything anyway. And in case there's a problem with the wiring, I want this off. So we'll run it, and then we'll flip it on, and if we can see if there's a problem. All right, so let me see. We're going to... Let's see if you can see it start. What's the best place to see? I think, give you a view of it. Hold on. By the starter. I'm going to hit the manual button and we'll check it out. Hopefully it'll start. switch quickly. Okay. I'll start it one more time. I had to go get my kids, so I had to interrupt it. But we'll start it again, and then we'll flip the switch to let power in the house. That'll just go to the transfer switch, and then it won't send it into the house, but it'll. If there's any problems with the wiring, we'll see it then. Okay, so I'll start it. I'll show you from the engine when it starts. I'll put it in manual mode again. Shut it off, and we'll put it in automatic mode. And it'll say, gotta hold it down. Everything here you have to hold down, hold down. Okay, so it says generator ready, and let's see if it'll start from the transfer switch. But first we'll close things up here. So my son wanted to try to start up the generator, which is good. So I'll take a video from the engine itself starting. Okay, Murray, you can hold down the manual button. Just hold down, not so hard, just push it. Any luck?
Not really.
Just hold it. Feel the power? Okay, shut it off. Hit the off button now. Hold down the off. Just hold it. Hold it. Good. We're going to test out the transfer switch to make sure that it's working in automatic mode. See if we can get some better lighting. There won't be much lighting. It's going to be dark. So basically what's going to happen is I'm going to shut off the power, and the generator is going to see no power, and it should turn on. After 10 seconds of no power, it turns on, and then it takes 50 seconds. I have the dip switch set, so it warms up for 50 seconds, and then it'll turn the power over to the generator. So the generator just warms up for 50 seconds. You can see over here my little, this shows you it's on, everything seems okay. So I don't know if you'll be able to see it, but over there, this little switch over here, a little wood stick, this over here is going to go down. Probably won't be able to see it because it'll be dark, and then we'll be on generator power. You can see the green light is on there on that little circuit board. The red light is not on because there's no generator power, and hopefully that should work. So we'll check that out. We'll shut off the power. I'd like to get you some light here, and we'll shut things off. Okay, so here we go. Ready, set, power outage. Okay, so it takes about 10 seconds for it to be out for the generator to turn on. Okay, it turned on. You can see that red light should go on. Yeah, it did. That's showing the generator power. Now it's set not to turn on to generator power for 50 seconds, so we'll just wait a little bit. And this over here, that switch should flip over. Hopefully you'll see it. Otherwise I hear it running, and we'll just hang out there here. Have my Harbor Freight flashlight there. Okay, we just gotta wait the 50 seconds. Something's happening. Okay, so it happened fast, but you can see, I'm trying to get the light here. This lighting is difficult. The switch over there, try to focus on it, is down. So that means we're on generator power. And just to show you, here's our gas meter. Look at that suck down the gas. What I want to tell you is just, it's really a nice engine. It's a 3-liter GM engine. And if you look at the Kohler and the Generac, they use a 2.4-liter engine. So this is really a full 3-liter engine. It's really running very smoothly, very nice. It's loud, and we'll check it out outside what it's like when it's running. But the other one, the 20 kilowatt, was actually louder. It had a very high-pitched running. It was running at 3,600 RPMs. But so far, so good. We seem to have enough gas. You can just hear it clicking. I don't know what is the baffles inside there. It's going through that 2-inch gas pipe. Beautiful. So let's go outside and we'll see what it looks like running within a power outage. Actually, before we go out, I just wanted to mention one other thing about the engine. It's a 3-liter engine, and it's basically, the engine is bought from GM by a company called Impco, IMPCO. They put in the whole fuel system, all of it, the valves, everything. They do the whole ignition system, the the spark plugs, the wires, the cap, rotor, everything. It's all that, the computer, it's all Impco, IMPCO. So I was able to get that manual. So I have all the parts for the parts catalog. So you don't really have to buy replacement parts from Briggs Stratton. You can buy it from on the internet, from Amazon or any place that sells Impco parts. If you are interested in the catalog, I'm happy to send it to you. Just post a simple message. Don't post anything about it because I'll delete your email right away. I'll delete the message. Just use if you can't send the @ sign, use the capital AT sign, and I'll email you the manual if you're interested. Or if you have any parts questions, I'll try to answer that. This way you can just get them cheaper off the internet. I'm going to post all the parts, the common replacement parts as well, on the description part of the video. But actually I'm very, very pleased. It's working nicely. You can see that the red light is on. I don't know if you can see there, but the red light's on, the green light's not, because there's no utility, it's just running on generator power. But it seems like a great engine, a great product, and I'd really recommend it. So we'll go outside and let's check it out. Alright, so it's all closed up. It's loudest over here. But it's kind of like a central air conditioning unit. It's louder than a central air conditioning unit, but it's not terrible. We're going to transfer back to utility power and show you what happens when the power goes on. Interestingly, I noticed the Symphony board is all lit up. It's showing like all the zones on the Symphony board. There you can have like 10 of them or so. They're all lit up. I don't know what that means. I'm not going to use it. In any event, we can probably do more of a stress test when I change the oil in the summer, because then I can turn on the ACs. I have them covered, so I can't turn them on. But I'll show you over here. So it goes in reverse. If you look at that switch that's down, that'll shoot up. So what we're going to do is we're going to turn the power back on. Turn it back on. This. Okay, and just watch that switch over there. Oh, okay, now we're back on utility power. And if you look at that light, now both are on. The green one is on because we're back on utility power. The red one's still on because the generator's still running. And it runs just to cool off. I think what did they say? It's somewhere between 1 and 5 minutes. The generator will turn off by itself. It'll be ready to start. If power goes out again, it'll be in automatic mode, so it'll be ready to start. And that's pretty much it. We're on utility power. The generator stays on just so it can cool off a little bit. If it just shut off, you want the oil to circulate while it's idling. So it's cooling off slowly, letting itself cool down. And then when it cools down, it'll shut itself off. Okay, but pretty much we're done. We'll put the cover on, and we're done there. With the hooking up the generator part, and I just want to show you the concrete guy came. He filled in the cracks around there. The hole was too big. He filled it in with concrete. I also wanted to show you just one other thing. I think when the generator was saying like CAN bus or something detected, I think what it's referring to is the generator has its own computer, which is over here. I mean, actually meant the engine. So the engine has its own computer, which handles probably the RPMs and it handles a lot of things that the main computer here used to handle in the 20 kilowatt generator. And the 20 kilowatt generator, this computer actually handled how fast the engine was spinning. It would measure the hertz, and if the load was too high, the hertz would drop below 60 hertz, and it would then raise it. It would then raise the throttle, the steeper motor throttle, and then bring it back up to 60 hertz. And if it was too high, it would do vice versa. The other thing, that's why I think the other computer also told me how many watts the generator was using, how much the load was. This didn't say too much, but because it's different. I think it's interfacing with that computer and working together. The other thing I want to note, I wasn't sure where the text notification system that Briggs sells would actually hook up here, and I think I found over here, somewhere over here. Where was it? Here. I found this connector. Oops. I don't know if that's anything. And over here, I'm not quite sure what you do with that. You pull those out? Are these caps that you pull off? Oh no, maybe the whole thing comes off. I think this whole thing comes off. So basically, if anyone knows what this is for, or if you have this on your your generator, if you have this hooked up to the text notification system, if that's where it goes, I'd appreciate if anyone knows about that. And pretty much we're done. I'll just show you going around the side. We even got the bush back in. We just have to fix that sprinkler head. Other than that, the benefit is you really can't see the generator from afar. And that's it. Look, I hope this video was helpful to you. Part of the purpose was to make a video to help you install the generator if you like, or just to learn about it, and also to get you the part numbers so it's cheaper to buy parts if you need it. And I hope this was helpful, and if you have any questions or comments, just post that.